Hello, Keith Rucker here at VintageMachinery.org. Guys, so today, got a little project we're going to be attempting to do. And when I say attempting, I'll be honest with you, I'm a little bit concerned about this one and whether we're going to be able to pull it off or not. What I've got here is a whistle. This is an old steam whistle. This one happens to be made by the Buckeye Brass Works out of Dayton, Ohio. Ironically, this is nearly identical to the Buckeye whistle that is on our steam locomotive out at the Georgia Museum of Agriculture. It's a 3-chime whistle, nice little whistle, but it's got one problem, and it's got a little tab broken off down here. This is where the lever is that you actually pull to blow the whistle. It has broken off, and I had a viewer reach out to me to ask if I could try to repair it. And I'm going to tell you just like I told him, I've had mixed luck trying to repair this broken brass and bronze stuff. Sometimes I can get in here and kind of braze it back together. It's really almost more like welding in this case because you're actually going to melt the brass in there and use some filler rod to fill it back in. But I've also ran into situations where when you put a little bit of heat on this brass, it doesn't create a puddle, it just kind of vaporizes and goes away. Don't know what's going to happen here. I flat out told him, I said, look, I'm willing to give it a try. I give a 50-50 chance. I can't guarantee that we're going to get results. I can't guarantee that it's going to be worth anything. He basically said the whistle is no good to him as it is right now. And he is willing to take the risk that we fail. And also that in the failure, we might make it worse than what it currently is. So if he's willing, I'm willing. So we're going to give it a shot here. Let's sit in here and get you guys to take a look at the problem. We're going to get in here and probably disassemble this as much as we can and see if we can get lucky and pull a braze job off or repair job off on this and fix this old whistle and put her back in service. So here is the whistle, and the part that's broken you can kind of see right here. It's broken off, and he sent along the broken piece. This is the part that needs to go back on there. And as you can see, it's got the lever that you pull to actually blow the whistle. So game plan here is we're going to take this apart as much as we can. We'll kind of V that out, see if we can get that clamp back together, and see if we can put it back together, weld it. Really, I guess this would be welding because we'll be melting the base material. I'm going to try using my TIG torch on this. I've had pretty good luck doing smaller profiles, a little more control with the TIG than I can with the flame welding, and it doesn't require near as much heat where I really need that flame to be able to get the heat in there. At least that's my game plan. So let's see what we can do. Let's see if we can get this thing taken apart first. So the chime just kind of unscrews from the top here. This is a 3-chime whistle. Most steam whistles just have a single chime, so basically the top is just one big dome, and when you blow it in there, it gives you one note. This one here actually has 3 different chambers, and each one of them is a little bit different in the height, and when you blow this, it actually blows 3 different notes that together makes a, I don't know if it'd be a chord or a chime or what, but basically it gives you that sound of the 3 different notes together like a chord would make. A little bit nicer sounding whistle than just a regular single chime whistle. So down here in the bottom, there's a nut on the back side here. Let's see if I can get that, go down a size. No, interesting. Huh. 3/4 is too big. 11/16 is too small. This nut has some wear on it. Let me see what I can find to get that off with. Move this over to the vise to kind of get a little bit better grip on it. The flats on this nut are pretty rolled over. Hopefully we can get this to come apart without messing things up worse. There we go. This is where the valve is, by the way. There's a couple of springs in here, and you got a valve that will open and shut. There's another spring on the back side. I got that one off, and now that valve should pull out, except there's a little, flip this around where you can see it. So if you look on this side, this is the side that presses up against that little lever, and it's kind of mushroomed over. I'm just going to take a file. It's got a little raised edge that won't let it slip through. I'm just going to take a little file, knock that burr off, and hopefully it'll come on out. There it comes. This valve just rides up against a little valve seat on the inside, and as long as we got that out, I may go ahead and lap that valve when we put this back together, assuming we're successful, and just make sure it's got a good seat in there. Well, as is often the case, work holding is one of your biggest challenges when working with something like this. I need to come up with a way to hold this tab in place while I was going to weld it in on here. And this is what I came up with. This pin down here is 5/16 inch that valve fit in. I found a 5/16 inch dowel rod over there that was about 3 inches long, 4 inches long, something like that. And I just welded a little tab onto the end of it that fit in here where this other piece is the same thickness as the rod that goes through here that connects to this, and I drilled a hole into that, connected it in place, put it in the vise, and it's pretty well lined up. So I think this is going to work from a work holding standpoint. So now we just need to get in here and see if we can get that to weld back together without disintegrating on me. And I'm not sure that we can do that, but we're going to sure give it a try. I did wire wheel this. I V'd out an area in there for my weld to go into. V'd out a pretty good chunk, and my plan is after I get this side done, I'm going to flip it over and get a die grinder, grind out the other side, and we'll weld that side as well, assuming this side goes well. So, and have a nice transition there. That's the game plan. This is, I'm pretty sure, red brass. And I don't know that I've got, well, I don't have any red brass filler rod. Probably just going to use some of my bronze TIG rods that I got over there and see if we can get that to work. We're just going to have to play with it. I could also maybe use a brass, a brazing rod, which is still a bronze, but it's more brass than bronze. We're just going to have to play around with it and see what works and keep our fingers crossed that we can make this work out. All right, guys, I think we are about ready. Just testing out, make sure I got good. Move my torch like I need to in there. We're going to try this with some silicon bronze. I just got some silicon bronze rod here. See how it goes. Only one way to find out. I'm going to start by introducing some heat kind of slow here. Get some heat introduced in there before I hit it too hard with the pedal. We don't have any preheat on this at all, so I'm just kind of doing that right now, getting a preheat in there. Slowly increasing my heat a little bit on the pedal. Starting to see a little bit of a puddle starting to form in there. Yeah, it's just jumped across there. Let that cool off a little bit, or just hitting it with the gas there until the gas turns off. That didn't look too bad. I don't know how strong it is, but it seems like it worked all right. Let's reposition it and get the other side ready to cut. All right, I'm going to take a die grinder and see if we can V us out a little spot there. Just changing to a different burr. All right, we're about halfway through the thickness. The other side was a little over halfway, so we're probably into that previous weld up underneath there, and we're going to go ahead and fill that in now. All right, and here we go again. All right, we're starting to get a little puddle in there. I think we got it again. All right, I'm gonna let this cool down, and we'll clean it up and see what it looks like. I think we're successful though, as long as that braze holds, and I think it will. We've let this cool down, and you can see it's all brazed back together. Not a bad color difference in there. Maybe just a little bit of a difference in the hue, but you get a little bit of tarnish on there. I don't think that'll show up at all. I did honestly go back and put a little extra braze on here just to try to give it a little bit more support, just to make sure that we had as much material in there as we can. There's a lot of leverage on this, and also ground the bottom out, braze the bottom up, and make sure we had a good connection in there as well. And probably overkill, but a repair that was made too strong will never break, right? That's my philosophy. So nothing too strong ever broke. I think I heard my friend Tom Lipton say that one time, and it struck home. So we're going to try to do the same thing here. All right, from here, what I want to do is, as long as I got this thing apart, we're going to go ahead and relap the seat of this of the valve in here. This goes in there. You basically just have a little tapered valve seat. I'm going to get some grinding compound, and we'll just relap that just to make sure we got a good seal. No reason not to do that since we're this far into it. And if the heat did any kind of small warpage or whatever, we should be able to straighten that out with a little good lapping on there. So let's set up to do that. For lapping, I'm going to use some of this Time Saver lapping compound. I just bought a long time ago, I bought a little sampler set that has a bunch of different grits. There's two different ones in here. The yellow cans are for soft metals. The green cans are for harder metals. So you would use this on like brass and bronze, and the green one's on steel. I'm going to start with coarse stuff here. This is a 40 grit. It's a powder, and I'm just going to take a little bit. It doesn't take a whole lot here. I'm just going to put a little bit into a cup here, and we're going to put a little oil in there with it. And I'll just mix that up into a slurry. Let's see, a little more oil. All right, and then I will take that slurry and I'll just brush some onto the valve here, and then we'll go over here and lap it. Now for lapping, I'm going to cheat a little bit. I'm going to put this valve into this drill, and I think I got enough here to, yeah. And we'll pull that out. And I'm going to put a little bit more lapping compound on here. We're going to do that several times until we kind of get that polished up all the way around there. Get that seated in. Now, this time saver compound is supposed to break down over time, so if you don't get it perfectly cleaned up, it's not supposed to cause a lot of damage. It will break down on its own, unlike some wrapping compounds, which are more explosive. I've always heard the story that this stuff was invented back during World War II by the Navy to help get engines done in a quick time, whereas if they didn't get it cleaned out perfectly, it would just break down and wouldn't hurt anything. I'm just reversing the drill there between shots, and just continue on here. All right, I'll wipe that off, and you can see that little polished area there. That is showing me that we've got a nice lap surface here, and I can look up in there and see the same thing. So what I'm going to do is I'm going to go through the grits. This was a course. I'm going to go through each of the grits down to a very fine, and we should have a nice, really lapped, polished surface after that. So I'm going to do that off camera, and we'll have this lapped in. So there is our newly lapped valve. The inside looks good as well. And I think we're ready to start putting this back together. Let's see. This is going to go in. Going to have a spring right here. And this little plate here will go back on there and tighten up. And once again, we'll use our adjustable wrench. Since everything is rounded over on this, too bad to get a regular wrench on it. Tighten that up. Now, that closes that up. So the spring is going to keep the valve closed until you move the lever, and that will open the valve up and blow the whistle. Next, we'll go ahead and put the chime back on. It just screws in from the top here. All right. I had this little spring on here. I'm not sure that that's really needed, but we'll put it back in there. And here is the lever, and there's a screw that goes in here that holds that in place. Yeah, the spring that's on here is not allowing it to open the valve up. I'm going to take that spring back out. I don't think it should be in there at all, to be honest with you. Let's try that again. Yep. That is what's supposed to happen. The spring will push it back out on its own. Shouldn't need any pressure coming back out that way. Well, there we go. That is it. I think what I'm going to do is see if I got some air that I can put on this, and we'll give this thing a blow and see how it sounds. Make sure that valve's holding, and make sure everything's not leaking or anything like that. So let me see if I can get an air nozzle or a air fitting plugged into this, and we'll try it out. All right, we got a little bit of air pressure on this. I will note that steam whistles blow better under steam than they do with air, but they will work on air. There's just something about the steam that gives them a better tone sound to them, but we're going to give it a try. I don't think that it's all the way up. I just turned the compressor on, but it's probably be too loud at full pressure, so let's hear what she sounds like. Seems to be working pretty good. I hear a little bit of air escaping in there. I'm not sure exactly what's going on, but that's not unusual. Whistle just not enough to make it blow. And like I said, if it was on steam, it'd sound a lot different, a lot louder. But I think this is a success. I think we've got this back together. Got the valve back in. It may be leaking air down here. I didn't tighten these fittings up real good. I hear a little bit of air escaping somewhere, but no big deal. I don't think it's anywhere. I don't feel it coming out around it anyway. I think it's fine. We're going to send it back and let them try it out. I like these little Buckeye whistles. They're cool. All right, guys, with that is a wrap. As always, thanks so much for watching. Please do subscribe to the channel if you haven't already. Those thumbs up and comments are always greatly appreciated. Hit that bell icon up there to get notifications when new videos are posted. Big, huge thank you to those who support the site financially through Patreon and PayPal. Leave a comment, leave a thumbs up. Really helps feed the algorithms. And with that, we're going to sign off. We'll catch you on the next video. Again, thanks for watching.